In the previous video, we talked about permutations, and then all we cared about was filling up a certain number of objects in a certain order. So ways of arranging 5 people in a line. And then it's just 5 times 4 times 3 times 2 times 1. Or 3 letters, 3 times 2 times 1. Well, there is also another way we can frame problems in terms of permutation. So basically, we're not just framing problems in terms of permutations. In reality, what we're doing is identifying when permutations can be used to solve real life problems. So it's important to have that clarified. So here, we're talking about using permutations of subsets from a larger set. So in this case, we have 5 possible lifeguards available at a swimming pool on Friday morning. But there are only 3 lifeguard stations. So you're in a swimming pool, there are 3 lifeguard stations. Let's say this is your swimming pool. One guy sits here, another guy or girl can be here, and say another guy or girl can be here. But they employ 5 people on staff. So here is a question for you. In how many ways can 3 lifeguards be chosen and ordered? So the ordering is important, right? Among the stations. So you have 5 guards to choose from, and then you want them to fill these 3 positions. So these could be the 3 positions written out where we've talked about them previously, and then you already know from the fundamental principles of counting, we're going to be multiplying n1 with n2 with n3. So how many lifeguards can fill up this first position? Let's assume this is position 1, this is position 2, this is position 3. 5 people, right? You have 5 lifeguards. So any of the 5 could fill up this first position. Now, one of them has filled up this position. How many lifeguards do you have left? 4. How many of the lifeguards can fill the second position? Those 4. Now you fill this position too. So one more lifeguard has been assigned. How many lifeguards do you have left? 3. How many of them can fill the last position? 3. So a number of ways you can select 3 lifeguards and order them among the 3 stations is 5 times 4, which is 20 times 3, which is 60. So that's the solution to this problem. So notice here we have to select 3 and then order them out of 5. Whereas previously we were just caring about ordering 5 guards, for instance, assuming there are 5 positions. So whenever you have a larger set and then you need to only fill up a smaller set and then ordering is important, then what you're doing is actually 5 permutation 3, which you will see shortly. So I hope that part was clear enough. The 5 permutation 3 part is where we are going to build up to. So there are 5 ways to choose a lifeguard to occupy the first position, right? So this is exactly what I explained. Then 4 ways to choose a lifeguard to occupy the second station, and 3 ways to choose a lifeguard to occupy the third position. So it's 5 times 4 times 3. Total number of permutations of 3 lifeguards chosen from 5 is 5 times 4 times 3, which is 60. And then we can generalize it as follows. The number of permutations of k objects chosen from a group of n objects, right? You're selecting k. In this case, you're selecting 3, right? From a group of n objects. N is what? 5. And so you start from n, 5 times 5 minus 1, 4, times 4 minus 1, 3. And you're going to stop here. How do you know what this is? N is 5, k is 3, and then you add 1. What is that? 5 minus 3 is 2. 2 plus 1 is what? 3. So you have to stop at 3. And we're already at 3. So we stop here. And that's precisely what the solution to the problem was. So this is the general formula. And then you can express this in a succinct form as follows. You realize Previously, we had talked about n factorial, right? Which is n times n minus 1 down to 1. Unlike this, which stops at n minus k plus 1. So we want to write it in terms of n factorial, which is what this is, divided by something. So we're going to divide by something. And we realize what we're dividing is by is n minus k, right? And so this multiplication will continue to n minus k plus 2, n minus k plus 1, to n minus k. And if you want to continue this multiplication beyond n minus k, you can write it as n minus k factorial, and this is n minus k factorial. And this gets you what? N factorial divided by n minus k factorial. Because this starts at n, each number is successively smaller, and then you get to n minus k and you keep going from n minus k to n minus k minus 1, and the final smallest value is going to be 1. So you keep going down all the way to 1, and this is n factorial up here. But we divide by n minus k factorial, so the calculation ends here. This term goes away, right? And this is precisely what this is. So all of this is to say that this calculation of selecting a subset out of a larger set and having the selection ordered is as simple as n permutation k, which is what this is called. So n permutation k, which I'm writing this way, is n factorial divided by n minus k factorial. That's the important point. And if we move on to combinations, I'll just jump to the final. I'll start from the end because it's related. This symbol is n choose k. So n combination k or n choose k, they mean the same thing. See, this is similar but different. For permutation, what we had was n factorial divided by what? N minus k factorial. This was permutation. So check out what is different here. You're also dividing by k factorial. So typically, your combination, your n combination k will be smaller than n permutation k, but sometimes they're just the same. It all depends on the numbers. Good. So what is the concept of combination? I already introduced it before, and here you just care about selection. So if you see the word selection and choosing and it stops there, then you're talking about combination. If you're talking about selection and choosing and ordering is important, then you're working on permutation. Very important to realize that. So the difference between combination and permutation is not the selection, is that with permutation you can select, but you have to also order. Order is important, whereas in combinations ordering is not important. So in some cases, when choosing a set of objects from a larger set, we do not care about ordering. We only care about which objects are chosen, right? So if you have 5 lifeguards and you want to choose 3 out of them, we don't care who is at which station. We don't care who is here, who is here, who is here. We just care about which of the 5 lifeguards were chosen. Is it lifeguards A, B, and C? Or is it lifeguards B, D, and E? So if you choose 3 lifeguards and there are lifeguards A, B, C, out of A, B, C, D, E, those are the 5 possible lifeguards, right? If you choose A, B, C, that's all that matters. We don't care whether it's C sitting in the first position, or it's B sitting in the first position, or it's A. What we care about is the basket of the 3 lifeguards. And you can see how that reduces the number, right? Because you will divide it basically by the different ways you can fill these 3 positions, which is what 3 factorial is. And that's why we divide by k factorial, which in this case is 3. So you will divide whatever we calculated from the previous case by k factorial if ordering is not important. So this is what the question will look like. Find the number of ways of choosing any 3 lifeguards from a group of 5 lifeguards. Pay attention to this. It's just choice of any 3 lifeguards. There is no conversation about the order. So that is combination. So number of ways of choosing any 3 lifeguards from a group of 5 lifeguards is just 5, choose 3. 5 combination 3. They all mean the same thing. And you can write it in this form, you can write it in this form. So you could have written it as 5 combination 3, and it's total number of lifeguards available 5 factorial. How many are you choosing? 3 factorial, and then n minus k, which is 5 minus 3, which is 2 factorial. And then this will be 5 times 4 times 3 factorial. Again, it's not important you continue to write it down, because one of these 2 numbers will typically truncate your calculations, and this makes it faster to calculate. So this is 3 factorial times 2 factorial. So 3 factorial cancels 3 factorial, and what you have is 20 divided by 2, which is 10. And you can see this is 10. The previous calculation was what? 60, because in that one ordering was important, and so we did 5 permutation 3, and that gave us basically 5 times 4 times 3 factorial divided by 2 factorial only, which is 60. And here we have divided it by 3 factorial, which is 6. And then you divide 60 by 10, and you divide 60 by 6, and you get 10.